Last speaker is Gary Rayner. He's a second-year master's student at Appalachian State University, pursuing a degree in geography and a certificate in planning. His focus is on issues of social justice and rural regions. Gary.
Okay, so good afternoon. As part of my thesis and my master's work, I'm looking at methamphetamine production in North Carolina, specifically visualizing it. In a lot of the previous research I've looked through, there's a lot of modeling, linear regression, geographic weighted regression, but there hasn't been really a lot of visualization for it, so I kind of wanted to fill that gap a little bit. So just to quickly start out, methamphetamine, it's basically a stimulant for pleasure centers of the brain. It's highly addictive. Most people find themselves addicted after the first try. And as far as methods, it can be smoked, snorted, eaten, or injected. There are some pretty serious human health consequences to it. You can have stroke, cardiac arrhythmia, increased blood pressure. Usually when people take it, they're up for 10 to 12 hours, just going straight kind of adrenaline. So they can sometimes develop hallucinations, paranoia, and can become anger and aggression. And they're finding out now that it's kind of almost a cycle where, particularly with the increase in opioid abuse, that because they're staying up so long, they start to experience pain from having that intense or being awake that long. And now they're kind of abusing opioids to kind of come down from that, and then they go back to the meth and back in kind of a cycle. But it could also cause loss of bone mass, damage to teeth, and death. And you can see from the picture, it's pretty hard on the physical appearance. Most people, when they take it, for this woman, for instance, the scars on her face, they kind of get the feeling that something's crawling underneath their skin, and they'll just continuously claw at it. So that's where most of them get those marks from. And the ingredients that go into it are pretty harsh. And this is just kind of a short list. They can use lantern fuel, battery acid, antifreeze, Drano, any kind of drain cleaning, paint thinner, and probably the one most people are familiar with, Sudafed, are products that include pseudoephedrine. And one reason it's important to know about the ingredients is they're extremely toxic. For 1 pound of finished product, you can usually have about 5 pounds of toxic waste, which is a pretty staggering ratio. Most producers will either bury it in the soil or just abandon it somewhere random. They're not going to throw it out in their backyard because that's super suspicious. And they usually won't dump it even kind of down the road because then you kind of pique law enforcement interest about what's going on in the region. So it gets buried, which kind of makes the soil unusable, and it can contaminate groundwater. And you also have the possibility of, while meth is being produced, releasing toxic gas and producing explosions, as well as harming other people who aren't even involved in production. And so I chose North Carolina not only because it's my home state, but for many of the years, we've had a lot of instances. This is data from the USDEA, and it involves kind of a combination of methamphetamine labs, where dump sites have been found, or kind of any paraphernalia that looks like it would have been used. And usually between every year that they have data for, we're usually somewhere in the top 10. Other states like Tennessee, Illinois, and Missouri, they usually have somewhere in the range of over 1,000. And we're usually somewhere between 500 and 600. So it's kind of a significant problem in North Carolina. And this is based on address information from the DEA. This is the amount of labs that were found by address by year. You can see starting out in 2004 and 2005, which is when they started data collection, there were a lot of labs that were discovered. And then in 2005, you had the passing of the Combat Methamphetamine Act of 2005, which is basically what forced you to buy Sudafed behind the counter. And we can see after that in North Carolina, there was at least a pretty significant drop-off. And other studies, such as one in Oregon, have kind of shown the same pattern. And then shortly after that, in 2010, we saw a second rise. And again, another act was passed. It was kind of an enhancement act to the original Combat Methamphetamine Act. And again, you can see after 2010, it kind of drops off again and then picks up again. And the only real purpose of that enhancement act, it basically just closed a loophole for people who could receive mail order medications. They could no longer receive like any amount of Sudafed by mail. So what I wanted to do is know where labs were in North Carolina. And to do that, I collected address data from the USDEA. They keep a running register of all addresses that are reported for all 50 states. So I converted that into a more manageable text file and then created a spreadsheet and then used an online service called Smarty Streets to geocode it and then produced an output with latitude and longitude coordinates for each lab address that could be mapped. And after that, we came up with basically a simple point shape file of all labs that were discovered. And even just by looking at it without any real analyzation, you can kind of see there's some pretty large clusters in western North Carolina and then kind of in the central part. But specifically, I wanted to answer just a few questions. Were the lab locations clustered? Where were they likely to be found? And how could decision makers or researchers use this kind of visualization to further their research? So as far as locations of labs being clustered, they're actually pretty clustered. It's a very low p-value, less than 0.01, and a very low z-score, which means there's pretty much no way it's by random chance. And we also found that the average observed distance between each lab was about a little over 2 miles. And why this is important beyond just basic curiosity is previous research has found that one way that methamphetamine kind of spreads is through the passing on of knowledge, because you can go online, YouTube, Google, and you can pretty much find out how to do this on your own. But because it involves a little bit of chemistry and other knowledge, you kind of need someone to show you how to do it the first time, just to make sure you don't kill yourself, releasing toxic gas or explosions or things like that. And then looking at clusters statewide, you can see over in the west, there's kind of 3, and they almost look equidistant clusters. The first one being, or the upper cluster being in Watauga County, and there's kind of like a string of it that runs along the Appalachian Mountain Range. And then below that, you have the biggest cluster, or the most intense, was in McDowell County around the town of Morganton, which kind of spreads over into Burke County. Or sorry, the biggest cluster is actually Marion in McDowell County, and then it kind of moves over to Burke County and Morganton. And then the cluster below that is located in Rutherford County, and it runs east, kind of along through Gaston County, and stops right a little bit into Mecklenburg County. And then the central highest density was located in southeastern Harnett County. And it was interesting to look at through all the years, methamphetamine production, it kind of looks like it didn't start statewide. If you look at it, it looks like it started specifically in the mountain region. And as the years progressed, it looks like it's kind of moved over throughout the state. So this was just a quick way of looking at the mean center of each point for each year. So for the first year, the green one, 2004, it was closer to the west. In 2005, it moved a little east. And then in 2006, just a little more east. And I stopped it there because going through the rest of the years at 2016, it doesn't really move much beyond that. So it's basically saying for the most part that most labs are still found in western North Carolina, but over the time period, you did see a shift east. As far as where labs are located, it's kind of common knowledge that there are generally in rural regions, but I just want to know specifically for North Carolina and for where they actually are located. For the majority, they are in rural regions, about 62% of them, with about 38% lying in urban areas. And this was just calculated by using a simple shapefile of urban clusters in major urbanized areas. And also to find out more about where the labs were located, we used a land cover raster in ArcGIS and used kind of like an aggregate extraction to find out which cells were around certain points. And it was kind of surprising because my first thought would have been, if you're producing meth, you want it to be really secluded, maybe in the woods and like your own little shack or something. But they're actually pretty much in kind of open, not extremely rural spaces, but kind of maybe like almost suburban areas. They're not really intensely developed. They're open, and they also occur around farming areas, with only a few actually occurring in areas that are like, say, deciduous forest, and then with the least occurring in areas that are really high density. Another thing we wanted to look at was road connectivity. For one reason, when you are producing, you kind of need a way to actually traffic it and move it out once you've made it. And I was kind of surprised. I looked at different road sets, interstates, state highways, and then just regular kind of service roads. And for service roads and highways, you could generally find one that was near it. But I was kind of surprised to find the numbers near major interstates, that 12% of all the points were within a mile of a major interstate, 30% were within 3 miles, and 39% were within 5 miles. And by looking at this, most of them occur actually along I-40, with that kind of middle cluster I showed earlier around the Morganton and Marion region, running west close to Asheville. And then a second cluster a little bit below Raleigh, kind of where I-40 intersects I-95, was another big area. So it was kind of interesting to be able to see that. And kind of where I wanted to go with this with further research is the things that go into making meth are complicated. I've looked at different models like ordinary least squares, geographic regression, Poisson regression using geographic weighted regression techniques. And my results haven't been that well, and neither really has it come up in previous research, like a really strong model, using just basic socioeconomic variables like median income, unemployment, or education. So what I would like to do in further research is kind of take it in a more mixed method approach instead of relying solely on quantitative data, to be able to integrate this data with something maybe like Google Earth and produce kind of like maps that could be taken into communities and sit down with people and ask them. They could be residents, they could be people who formerly were producers, and find out what specifically drove them to it. Because even though we know maybe it is because it's an area of low income or high unemployment, there's not really like one major thing you can do to correct that. So I would like to go in and kind of ask people, what would help them, what kind of maybe barriers they face in their region, whether they're physical or social, and just try to collect more data that goes beyond just the basic census data that we usually work with. For instance, in that left image for Marion, all those points occurred relatively close together and within the same time period. So it would be interesting to know if they actually participated in passing on knowledge to figure out how to produce meth, or for whatever other reason. And then also looking at a little closer at what type of landscapes do meth labs usually appear in using Google Earth. And then that was the end. If you have any questions, I'd be glad to answer.